All right. Today we're troubleshooting triple nickel again. I plugged it in and immediately went bzzz. It really did not like being plugged into power, so I'm checking doing a continuity test to find out. Oh yeah, there's I think it's the motor, honestly, but I don't know. That was flipping the breaker. Well, let's tear into this and see what's going on. What I should have done was grabbed something with the... Let me see if I can disconnect the battery. I want to disconnect the battery first. Let's see. There's 2 quick screws right here. All right, that disconnected the motor. I really wish I had a switch box in here that I could plug this into. Nope.
Still did it.
I don't know what that noise is making back there either. It's pretty loud.
Yeah.
All right, well, let's get it pulled apart, see what's causing that. It was not the motor. All right, so what are we going to do now? Let's see. Did we watch to see if this triggered at all when we turned it on?
No, we did not.
I don't believe it did. I didn't hear any clicks.
No.
Power's coming in. There's the ground. Oh, you know what? It goes right into one of our little old buddies, a bridge rectifier.
Oh.
Let's have a look at that.
Bridge rectifier's blowing in.
I'm hoping so. I'm really hoping so, because it's a rare treat that we get to fix one of these. So you got a picture of where all these wires go.
Yep.
And of course we are unpowered. Let's see where we got right here. There. That was on the other thing. All right, here's how we test the bridge rectifier. If I can get it in there. What is hanging me up here? There, good enough. Anyways, let's put this over to diode mode. So we hit select. Right there, we're in diode mode. So now that we're in diode mode, we can test these the diodes in this rectifier. I always go from corner to corner. I'm usually looking for around 1 to 1.4. Oops. You know what? Let's just make life easy on ourselves because I believe this is bad already. I already looked at it and it said 0.4, and I don't believe that's even close to being accurate. Let's see. Yeah, this is that side. I'm sorry, yeah. Yeah, let's get that. What size is that? Probably not that size. It's probably on the other side. Oh. Boy, I love having options. Where are we at here? You know what? There we go. Third time's the charm. You know what? I was even on the wrong one again. Ah,
Oh,
rats. It's not that one. Come on, we got to do this. There we go. Good enough for me. Not that screwdriver.
Right there, it fell on the ground, it looks like.
Yep. There we go. This is the bridge rectifier. Looks like the goop is almost gone, the thermal grease. So let's have a quick reading of it. Zero 0.42415. I don't think that's right. Yeah, looky there. That's dead.
Dead. Yep.
Now let's go the opposite direction and make sure. Yeah, that reads as a direct short to me. That is open. So what this is actually 4 diodes. That's actually a good diode there, I believe. Shorted. Shorted. So what we have here is we have a diode that goes from one direction, points to the next. They all go into a circle or whatever, and AC comes in, it blocks, and DC comes out on one side or the other. I don't recall. I believe this is positive, but don't quote me on that. Yes, you can quote me on that. So we got a positive right here, and we have a negative right back here. See, we got 0. Let's try this again. See, 0.411, I'm always expecting around 0.1 or so, or 1.0, 1.4. That one's good. That one's bad. Anyways, that's how we read them. I'm going to go look in my bag of tricks and see if I have one of these, but I believe I do. We'll get back to you when we're done with this. This is the curve bug tracer, curve tracer. It's basically a comparator, signature maker, whatever. So what I'm going to do is show you the comparisons between the bad and the good. Let's start with our known bad one, which was this one. This one right here, I believe. It's a GBC 3506, 35 amp, 400 volts bridge rectifier. So if I go use here, this is a negative post. If I compare the difference between that negative and either side of this, they should be the same. You can already see some stray capacitance right there in the weak signal, which is a bad sign. And then I put this one on, you can see it's a direct short, like I suspected. So your AC is getting converted over to, likely getting converted to DC and then pushed back into the power system. And that's what it should not look like. You can see that they are identical, and this is a direct short. This should be double the output, so it should look something more like this. So as you can see, well, there's some capacitance in there. Maybe it's okay. But anyways, you can see the signals are nearly the same. This looks like the one that's getting weak. You can see the dark signal is a little bit lower. So this one I believe is getting weak, but if I do this, you can see it doubles the strength. I'm gonna leave that one out as a weak. Let's try this one here. All right, so it looks like it should have some capacitors. Wow, that one is definitely not happy. But we still have a good one. Oh, you know what? There's my capacitance. I just lost it. That's where the stray capacitance was coming from. So now I need to find me another lead of sorts. See what we got here. Well, anyways, I'm just going to continue to test them. Nothing changes. You can go to the positive side here and then check both sides. The capacitance is still probably coming through me, or it's normal. I don't know. You can see the double signal. That one is not one I'm going to use. This is the one I found that will actually work. It's 33 amp, 200 volts, so it's the only one that has a chance. But you can see it has a pretty nice signal strength and everything. So we're going to put this in and have a look at it. All right, I looked at the motor and it's a 7.7 amp 1 horse motor, DC. So I'm going to try this 10 amp one first, see how it does. If it has problems, then I'm going to put in the 33 amp one. Let's plug this in and hope for the best. I should have brought another thing to test that with. No noise, no noise. Now let's test the, let's kill the power again. And this time we're going to test the pendulum to see if it switches power for me. If I can remember where that pendulum went to. There it is. Oh, pendulum's already in. Let's plug the power in and give it a shot. This is not going to run the motor, but it should run the relays. The contactors. It's running the contactors. That's band. That's unload. Off. Okay, let's plug the power motor back in and hope for the best. Something burned up that rectifier, and I'm hoping it's not the motor. But you know what? Let's meter that motor real quick. Let's see what it looks like on this signature analyzer. Oh, it shows a direct short, but let's check the meter. That scares me. But then again, I'm still new to using this curve tracer. I just have it in continuity mode. Yeah, that is probably not good. 1.2 ohms. I think I'm gonna try it, but just tap it and hope that it just knocks the breaker loose, and that should be what it does. But at a 10 amp weak one, I'm not too concerned. I just don't want to burn up my 30 amp one before I get a chance to use it. Oh, hi, buddy. Yeah. You having fun, bud? Ooh, I didn't kill the thing, so here we go. Cross your fingers. Let's get this out of the way. Reverse. Forward. Job is finished. If we need to, if it burns up again, which it shouldn't, it'd be really hard to burn it up, then we'll come back and replace that with bigger bridge rectifier, but that was our problem.